Does anybody know what the definition of an isosceles triangle is?
Two sides are the same and one side's not.
Anybody else want to take a different shot at it? That's why I said probably isosceles, there might be some misconceptions. Isosceles triangle says at least two congruent sides. Is an equilateral triangle isosceles then? Yes. Now, the reason the picture is over here is they've marked two sides as being congruent, and it's important to know that that top angle that's fastening those two sides together that are congruent is called the vertex angle. And then the two angles that are on the bottom sides of those congruent sides are called the base angles. The isosceles triangle theorem says if two sides of a triangle are congruent, in other words, they know that these two sides are congruent. And I'm going to label it. They know that AB is congruent to BC. Then the angles opposite those sides are congruent. In other words, angle A is going to be congruent to angle C. Questions on what it means to be isosceles? Important to know the vertex angle is attaching the two sides that are, two sides that are congruent, and that these are the base angles. Everybody good? So let's take a look at an example. If segment DE is congruent to segment DC, what should I do with that information when I'm looking at this picture? I'd better mark it. DE is congruent to DC. What type of triangle does that make triangle CDE?
Isosceles.
Makes it isosceles. Segment BC is congruent to segment AC. What type of triangle does that make BCA? It's isosceles. Angle CDE is 120 degrees. So I'm going to put that in right here. And they asked me to find the measure of angle BAC. In other words, they're looking for the value of x here in this corner. Well, I'm going to start where we have a measurement. I'm just going to look over here. What's not marked in this picture that could be marked because it's an isosceles triangle? If the two sides are congruent, what can you tell me about the two angles that are opposite those sides? They're congruent. How many degrees are in a triangle? 180 degrees in a triangle. How many have I used up? So there's how much left? And I have two angles that are the same, that has to be split between. What am I going to do with that 60? Divide it by, so this is 30 degrees. If this angle is 30 degrees, can I use that information in the other triangle?
Yeah, the vertical angle.
The vertical angle. So I know that this is also what? 30 degrees. And now I can focus on just this triangle that's over here. It's an isosceles triangle as well. So what do I know about its base angles? They're congruent. So angle B and angle A are the same. How many degrees are in a triangle? 180. How many have I used? I've used up 30. There is 150 degrees left in this triangle. What do I have to do to that number? I've got to divide it by 2, so the angles that are left are 75 degrees. So that is the answer to my question. 75 degrees. Questions on this first example? Am I good? Can I go forward? Example 2. Here they want me to find the value of x. This time they're not looking for an angle measurement. They're looking for a side. Please don't get confused about things that are on the outside compared to things that are on the inside. Does the outside have to add up to 180? No, only what? Only the inside of a triangle. So this has nothing to do with 180 degrees. Pardon me, 180 degrees. If I look at the whole triangle, if I look at it as a whole, what type of triangle is it? It's isosceles. What does that tell me about the two angles that are opposite the two congruent sides? They're congruent. What if I were looking at them now individually? What if I was looking at this triangle and I wanted to compare it to this triangle? What can you tell me about those two triangles? Yep. Can you tell me why? You're right. Angle, side, angle. So I know that those are congruent triangles. How big is x? X has got to be 9. That's the corresponding side. It has to be the same value. Everybody good with example 2? In example 3, I see that I have an isosceles triangle ABY. I see I have an isosceles triangle BYC. So, if I'm looking at it, they're saying the measure of angle ABC, this whole angle, is 110 degrees. If this whole thing is 110 and 30 of it is over here, how much is on the other side? 80. again, if I'm looking at this triangle, what type of triangle is it? Do we see it? What type of triangle is it?
Oh, isosceles.
It's isosceles. So this angle and this angle that's over here have to be what? Congruent. This is also going to be what? 80. So I've got 80 and I've got 80. I've used up 160 degrees of my triangle. How big is the one that's left? 180 minus 160. Y has got to be 20 degrees. Could we find these that are over here? In fact, how big would these be? If this is 30 up here, how big would these two be? Do you see it? Somebody said it. They'd be 75. I can see that this is also isosceles. These two angles would in fact be the same. I've used up 30, so there's 150 left. And 150 divided by 2, both of these would have been 75 degrees. Everybody good? Remember that when you're talking about a converse, you're stating things in the exact opposite order. Before we said if it's an isosceles triangle, which meant two sides were congruent, then the base angles would be congruent, the sides opposite. Here it says if two angles of the triangle are congruent, then the sides opposite those angles are congruent. So here what they're telling me is if angle A is congruent to angle B, and that's what they've marked as being in the picture, then what do I know has to be true? Well, what's the side opposite of A? The side opposite of A. CB or BC. What's the side opposite angle B? So if I know that these two angles are congruent, then the sides that are opposite those angles also have to be congruent. Everybody okay with the converse? If I go to the next slide, still writing. Okay. Example 3. Name two unmarked congruent angles. Which triangle is that going to come out of? Is that going to come out of PLM or MLN? They want me to name two unmarked congruent angles. It's going to come out of this one because these two sides are congruent. So what do I know about the angles opposite those two sides? They're congruent. Now, I can call this one angle N. Can I call this angle L? I can't call it angle L. Why? There's more than one angle there. Angle M, L, N. I'm going to list it with 3 points. I could have said NLM so long as L is in the center. It's got to be the vertex of that angle. Name two unmarked congruent sides. That's coming from the other triangle. Segment, whoops, PM is going to be congruent to segment PL because they are across from congruent angles. You know what? There's something missing here. This was here. Where's it marked? It got erased on my picture. I know it's good on yours. Yeah, it's this angle, and this angle, this side, and this side. Name two unmarked congruent angles. What triangle are the unmarked congruent angles going to come out of? ARB, AQB, or APB? AQB, because that's where the two congruent sides are. So I'm just going to trace that out real quick so that you can see it. There's my congruent sides. Which angles have to be congruent? If this triangle was separate, okay, if it was separate, this would have been where A was, this would have been where B is, and those would have been the two angles that had to be congruent, right? But the triangle wasn't separate. Can I call it angle A anymore? No. What do I have to call it? BAQ? Could have also been called QAB, so long as A is in the middle. And the other angle would have been ABQ. Could have been QBA, so long as B was in the middle. That's funny. Now, what's the two unmarked congruent sides? AR and AR, not AB, is congruent to BR. Everybody good? Equilateral triangle. An equilateral triangle is equilateral if and only if it has three congruent sides. If the three sides are congruent, what can you tell me about the three angles? They're also congruent because I know that opposite of two sides would have been congruent angles, But if I turned it the other way, we would have been able to see that this would have also been the same. So all three angles have to be the same. How big does that make each angle measure in an isosceles triangle? 60 degrees. We all good? This is out of your workbook today. And it is page 107, 108.